morning. Welcome to e-learning. I am P. Saktivel, Assistant Professor, Department of EEE, Tandai Periyar Government Institute of Technology, Vellore. Today's topic, step down and step up choppers. Step down chopper. It is also known as type A or first quadrant chopper. In step down chopper, output voltage is less than the input voltage. This chopper is represented by a switch. It is the diagram of the step down chopper. Here the chopper is represented by a switch. In the step down chopper, during the period T on, the chopper is on and the load voltage is equal to the source voltage. When the switch is on, the source voltage presents across the load. So load voltage is equal to the source voltage. During the period T off, the chopper is off, that is the switch is open and the load current flows through the freewheeling diode and the load voltage is 0. So when the switch is open, this load current I0 freewheels through the freewheeling diode, where the freewheeling diode makes a short circuit across the load. So the voltage across the load is equal to the short circuit voltage, that is 0. This diagram shows the output voltage and current waveform for the step down chopper. During the period of T on, the load voltage equal to the source voltage. During the period of T off, the load voltage is 0. At the same time, during the period of T on, the load current increases from I minimum to I max. During the period of T max, the load current decreases from I max to I minimum. Output voltage calculations. During T on, load current rises to I2. During T off, load current decays to I1. Now we calculate the average load voltage. Average load voltage is given by V0. V0 equal to the on period T on divided by T on plus T off into Vs, where Vs is the supply voltage. Now T on divided by this T on plus T off gives the T. So T on by T into Vs. This T on by T is known as duty cycle and represented by alpha. So V0 equal to alpha into Vs. Consider this as equation number 1. Here the specifications are T equal to T on plus T off is known as chopping period, where T on is the on time, T off is the off time. Alpha equal to T on by T is known as duty cycle. Always the value of alpha, that is duty cycle, is less than 1. The load voltage can be controlled by varying the duty cycle alpha. Of equation 1 shows that the load voltage is independent of load current, but it can be written as V0 equal to alpha into Vs, where alpha equal to T on by T. Now 1 by T can be written as F. V0 equal to F into T on into Vs, where F equal to 1 by T is the chopping frequency. The step down chopper is the first quadrant chopper. Here, in the first quadrant, both output voltage and current are positive. Next one, step up or type B or second quadrant chopper. In the step up chopper, average output voltage is greater than the input voltage. The basic diagram for the step up chopper is shown here. This Vs is the source voltage, L is the inductor, and chopper is represented by the switch, and this D is the diode. It is the equivalent circuit when chopper is on. So now the chopper is make and short circuit switch. Now the current flows through Vs, L, chopper, and Vs. When the chopper is switched on during T on, the current flows through the path Vs, L, chopper, and Vs. Also, inductor stores the energy. When chopper is on, source voltage is applied to the inductor. Because the voltage across the chopper is 0. So whatever be the voltage of the source presence in your inductor. So VL equal to Vs. It is the equivalent circuit when the chopper is off. The off chopper is represented by an open circuit. Now both the source voltage and the voltage across the inductor act as the source. Now it both supplies the current to the load. When chopper is switched off, the inductor current is forced to flow through the diode and load for a time t off. As a result, voltage across the load is given by V0 equal to Vs plus VL. From this, VL equal to V0 minus Vs, that is the voltage across the inductor equal to output voltage minus the input voltage. These are the waveforms of output voltage and current for step-up chopper. So in the step-up chopper, during the period of T on, the output voltage is 0. During the period of T off, the output voltage equal to the source voltage. When the chopper is turned on, the current through the inductance L will increase from I1 to I2. During the period of T on, the current increases from I1 to I2, and during the period of T off, the current decreases from I2 to I1. The step-up chopper operates in the second quadrant. In the second quadrant, V0 is positive and I0 is negative. Output voltage calculation. During T on, energy input to the inductor is represented by W in. W in equal to voltage across the inductor, average current through the inductor into T on. Now the voltage across the inductor is given by Vs and average current through the inductor is given by I1 plus I2 by 2 and T on. Consider this as equation number 1. During T off, energy is released by the inductor to the load and is represented by W off. W off equal to voltage across the inductor into average current through the inductor into T off. W off equal to voltage across the inductor is now equal to V0 minus Vs into average current through the inductor is given by I1 plus I2 by 2 into T off. Consider this as equation number 2. At steady state conditions, this W in equal to W off. So equating equation numbers 1 and 2. In both left hand side and right hand side, I1 plus I2 by 2 will get cancels. Now Vs into T on equal to expanding this V0 into T off minus Vs into T off. Now bring this V0 T off on one side and Vs on another side. So here V0 T off equal to Vs into T on plus T off. T on plus T off equal to T. So V0 equal to Vs into T by T off. And T off can be written as T minus T on and divide by T, both the numerator and denominator. So we get V0 equal to Vs into 1 by 1 minus alpha. From the above equation, average voltage across the load can be stepped up by varying the duty cycle. If chopper is off, alpha equal to 0 and V0 equal to Vs. If chopper is on, alpha equal to 1, V0 equal to infinite. Thank you.